This week we are going to talk about how to solve linear inequalities. And the first thing I want to point out is sometimes you're going to see them referred to as linear inequalities, and sometimes you will see them referred to as a simple linear inequality. So those two are the same thing. So if you see simple linear inequality and linear inequality, don't worry, they mean the same thing. So take a few minutes to read this page, read the objectives, the vocabulary, read about linear inequalities, solving linear inequalities, and then also compound inequalities. And when you're ready, restart the video and we'll go through some examples. All right, the first thing we need to talk about when it comes to a linear inequality is the solution set. So the solution set is basically the answer to a linear inequality. And a solution set will always contain two things. It'll contain an interval and a graph. An interval is a range of numbers written in interval notation using brackets or parentheses, or a combination of the two. So sometimes we might have a bracket with a parenthesis and they might switch sides. A graph is just a picture of the solution set, or it's actually just a picture of that interval on a number line. Okay, so the two examples below will illustrate a subtle difference between when we use brackets and when we use parentheses. So on the left-hand side, we see an interval that says x is less than or equal to 6. And whenever we see less than or equal to 6, we know that our solution set is going to involve brackets. So if I think about this, the interval is just a range of numbers. Well, if x is less than or equal to 6, that means it could be anything less than or equal to 6. So that means that our lowest number that x could be is negative infinity, and the highest number that x could be is 6. And since we have less than or equal to, we need to use a bracket with the 6, because that bracket says, hey, I need to include that 6 in my solution set. And then if you look at the helpful hint down at the bottom, it says we always use parentheses with positive and negative infinity. So we're going to use a parenthesis. So there you can see we already have a combination of the two. We have a parenthesis and a bracket. Okay, if we're going to graph this, it's really straightforward to translate an interval into a graph. So we just simply draw a number line. And we only need one number on that number line in this case. So we just need the number 6. And I'm going to draw a little bracket right there. Whoops, that's not a very good one. There we go. And since it's negative infinity, I'm going to shade everything to the left of 6. So I'm just going to make a little squiggly line all along the number line. That represents all the numbers in that area. And then I'm going to shade in the arrow on the end. So there we go. That is a picture of that interval on a number line. Okay, and so you can see how we had to use a bracket in that case. All right, let's go to the right. On the right, this one, you'll notice that it says x is greater than 6. Okay, so there's no equal part to it. So it's just the greater than symbol. So in this case, whenever we have the greater than symbol and the x on the left-hand side, that can kind of confuse some people. So what I like to suggest is just take the entire inequality and flip it over. So instead of having x is greater than 6, write it as 6 is less than x. Okay, so what this does is it really helps us visualize now on a number line. If we read this the same way we did before, x is greater than 6. Well, so what we want is every single number bigger than 6. So if we think about our interval, our smallest number is going to be 6. Our largest number is going to be infinity. And remember, with infinity, we always use a parenthesis. And then with greater than, without the equal part, we also want to use a parenthesis. So we're going to use a parenthesis with the 6. Okay, so this is telling me that this interval is everything bigger than 6, but not including 6. Okay, and same thing to graph this thing, we're going to draw a number line, and I only need one number on that number line. I'm going to put a 6 there. And then where I put that little hash mark to indicate the number 6, I'm also going to put a parenthesis. So I'm going to draw a parenthesis there. Whoops, that's not very good. Let me do that again. Try again. Same thing. There we go, that's better. So it's basically right on top of that hash mark, and then I'm going to shade everything to the right. So this indicates every single number to the right of 6, or to positive infinity. Okay, and you'll notice in both of these cases, we don't actually write infinity on the number line. What represents infinity is the shading of the arrow at the end of the number line. All right, so that's a solution set. Let's look at some examples. So these are a couple of basic linear inequalities. And what we have here is we basically have an equation. So we could look at this and say, hey, x plus 4 equals negative 6. We're going to do exactly the same thing to this linear inequality that we would do if this were an equation. So we're just going to solve it, and we're going to get x all by itself. So the first thing I want to do to solve this is I want to subtract 4 from both sides. Okay, so I end up with x is less than or equal to two negatives, just add them together and keep it negative, so it's negative 10. So x is less than or equal to negative 10. All right, so if I want to write this in the form of an interval, I'm going to say, okay, x is less than or equal to negative 10. So everything towards negative infinity. So I know I need negative infinity, and I know I need negative 10. And then since it's less than or equal to, I'm going to put a bracket with the negative 10. And then remember, always use a parenthesis with positive and negative infinity. Okay, and then I'll translate that into a picture on a number line. And the picture is going to start at negative 10 with a bracket there. And it's going to go everything to the left, or towards negative infinity. So I'm going to go ahead and shade that in, and shade in the arrow as well. Okay. All right. So this next one illustrates something that is completely different when it comes to linear inequalities. There is something we need to do whenever we multiply or divide by a negative number. And what we need to do is we need to flip the inequality symbol if we multiply or divide by a negative number. So it says it down here in the box, and I'll highlight it for you so you make sure you see it. So anytime we multiply or divide by a negative number, we're going to flip the inequality symbol. So in this case, we have negative 2x is less than or equal to negative 4. So that negative 2x is the thing that I'm going to look at and say, oh, I need to do something after I divide by a negative 2. So I'm dividing by negative 2, and when I do so, I have x, but I need to flip the symbol around. So it's going to be greater than or equal to, x is greater than or equal to positive 2. Okay, and like we did before, it's always nice to have the symbol always facing to the right-hand side. So when I say facing, what I mean is the big opening on the greater than symbol. Let's flip it around so it's on the right-hand side. So I'm going to write this as 2 here, and then it's going to be flipped around again. So we had to flip a couple times. But so these two intervals, or sorry, these two inequalities that I've just written are exactly the same thing. We've just totally flipped it around so it's facing the other direction. And the reason I like to do that is because it really makes writing the interval and the graph really simple, because we can look at that x and say, hey, if that x is on the right-hand side, I know I'm going to have positive infinity, which is always going to have a parenthesis, and I'm going to have a 2, and then I just need to decide, is it a bracket or a parenthesis? Well, in this case, it's 2 is less than or equal to, so it's going to be a bracket. And then we can also draw a picture on a number line. Again, we just need one number, and since there's a bracket with the 2, I'm going to put a bracket, and notice how the brackets face the same way. So that's another thing to look at to check your work. Make sure your brackets are facing the same way, or your parentheses if you're using parentheses. And then that infinity is represented by shading the arrow. Okay, let's keep rolling. All right, a couple of more examples. 2x is less than negative 6. All right, so this one is very similar to the one we just did, except it had a negative 2, right? And then the big difference is the inequality symbol. There's no equal to part of it. It's just less than. So we're going to solve this just like we would a regular equation, divide by 2. So we have x is less than negative 3. Okay, so some of you are looking at that saying, hey, you got a negative number involved. Shouldn't we be flipping the symbol? Nope. We divided by a positive number, so we don't have to flip the symbol. If we get a negative number in our linear inequality, that's fine. It only matters what we divide by as to whether or not we flip the symbol. Okay, so x is on the left-hand side, so that means negative infinity. Negative infinity always uses a parenthesis. And the other number we need is negative 3, and since it's just less than, we're going to use a parenthesis here as well. Okay, so our interval is from negative infinity to negative 3. And then we can also graph that on a number line to draw a little picture so we can see all the numbers that it represents. So we're going to throw a negative 3 in the middle. And we're going to put a parenthesis facing to the left. And then we fill everything in, shade everything in, all the way to negative infinity. There we go. Okay, the next one. So the next one, two-step equation, right? One thing we want to notice right away, hey, I've got a negative 4 with my x. I'm going to be dividing by a negative number, so I'm going to need to flip that symbol in the middle when I'm at that point. So let's start by subtracting 7 from both sides. So we have negative 4x is greater than or equal to negative 16. Okay, and then here's where I'm dividing by a negative 4, so we really need to be careful. So we have x, flip the symbol, x is less than or equal to positive 4. Okay, so then the interval, just like the previous one, x is on the left-hand side, so we're going to use negative infinity. We always use a parenthesis with negative infinity. We have less than or equal to with the 4, so that means we're going to use a bracket. And then for graphing, we have something very similar. We're going towards negative infinity, so we just need to have the number 4 on there. We'll put a little bracket in there, and then we'll shade everything to the left. There we go. All right, let's keep going. Oh boy. So this one throws at us distributing, combining like terms, doing a whole bunch of stuff. So let's just get cruising on this thing. So we're going to distribute the 2 on the left-hand side, the 3 on the right-hand side. I'm going to do those both at the same time. So we have 2x minus 6 minus 5 less than or equal to 3x plus 6. Now some of you might be tempted to just do multiple steps at a time here. That's fine. Sometimes it's easy to make mistakes when you try and do more than one thing at a time. And what I mean is when you distribute, you might try to combine that negative 6 and negative 5 at the same time. And that's fine if you want to try and do that, but just be careful because it's easy to make mistakes when you try and do more than one thing at a time. So we're going to combine like terms. So if I use my shading method here, if we're combining like terms, those are the only 2 I'm going to combine for right now. So I have, they're both negative, so that makes them negative 11. So we have 2x minus 11 is less than or equal to 3x plus 6. Okay, so now we have variables on both sides. And so we just have to solve this like we would any other equation where we have variables on both sides. So we take the smaller variable and we'll move that one first. So I'm going to subtract 2x. And so the 2x's cancel, so I have negative 11 is less than or equal to x plus 6. Now, with linear inequalities, it's really helpful to always take the smaller variable because then you don't end up with a negative coefficient on the x that you're going to divide by and force you to flip the symbol. So something to think about. All right, so we're going to subtract 6. So we have negative 17 is less than or equal to x. And then this is another one where I like to have that opening on the right-hand side, so it's there already, but the x is on the right-hand side. So that can be a little bit uncomfortable for some people, but that's okay to have the x on the right-hand side. It shows us that, hey, we're going to that positive infinity side, right? So over here on the right, I'm going to go ahead and write my interval. So my interval is from negative 17 to positive infinity. And always a parenthesis with positive infinity. And then since we have x is greater than or equal to, we're going to use a bracket on the 17. Okay, and then we can graph this. Just need one number, so we're going to use a bracket. So I'm just going to go ahead and write the bracket in there, negative 17. And then shading towards positive infinity. Okay, let's keep rolling. What do we got next? Oh, compound inequalities. Okay, so compound inequalities, compound just means more than one or two in this case. So a regular inequality that contains just one symbol is called a simple linear inequality or a linear inequality. But if we have two symbols, like you see here, we call it a compound inequality. But really, it's just two simple linear inequalities wrapped up into one. So if you look in the blue box, you can see a couple of examples. The compound inequality, 2 is less than x, which is less than or equal to 4, is really just 2 is less than x and x is less than or equal to 4. Okay, so it's those two inequalities. So a compound inequality solution will always contain a solution set in a graph, just like regular linear inequalities. And the solution set in graph will look a little different than a simple linear inequality. So it says, what is the solution to the following compound inequality? So to give you an example, if we have a compound inequality that looks like this, our interval is going to contain the two numbers that are on either side. So our interval is going to have 2 and 4 in it. And then we just have to decide on what type of container, a bracket or a parenthesis based on the symbol. So since we don't have equality on the left-hand symbol, we're going to use a parenthesis. And we do have equality on the right-hand symbol, we're going to use a bracket. So we have an interval that has a bracket and a parenthesis from 2 to 4. And then if we graph this thing, we now need to have two numbers on the number line. So we're going to have 2 and we're going to have 4. And then we'll just put the exact same symbols that we have in our interval. So I'm going to put a bracket here on the right-hand side and a parenthesis on the left-hand side. And I'm going to shade in between. So this is telling me I want every single number between 2 and 4, but I don't want the number 2, and I do want the number 4. Okay, so that's how you can read that. All right, let's look at a couple of examples here. I went too far. Here we go. So to solve a compound inequality, this is where it gets a little bit different too, because we have two symbols in there. We apply the same process, except we don't just solve on two sides like we do with simple inequalities, or like an equation where everything we do on one side we do on the other. Since we have two symbols we're dealing with here, we have to solve on the left, middle, and the right. So anything we do to the middle, we have to do it to the left and the right as well. And the goal is to isolate the variable in the middle. All right, so if we look at this, the first thing we can do to isolate the variable in the middle is just add 3 to both sides. I said both sides. Actually, we are doing it on both sides because both sides and the middle. So we're going to put plus 3, plus 3, plus 3. So everything you do, you'll see it 3 times. All right, so when we add 3 to -1, we get positive 2. And then in the middle, we're just going to have 2x. And then on the right, we're going to have 8. Okay, and then we can divide by 2 all across. So we have 1 is less than or equal to x, which is less than 4. All right, so that's not so bad. It's just remembering that you have, whatever you do in the middle, you want to do on the left-hand side and the right-hand side. Okay, so our interval is going to go from 1 to 4. We have equality on the left, no equality on the right, so we have a bracket and a parenthesis. And then we are going to graph this. So remember, two numbers on the number line, so I'm going to put a 1 like that. And notice how I just went straight to my symbols instead of drawing my little hash marks. So I go from 1 to 4, and then I shade everything in between. Okay, so that's not so bad. Just remember to do things, whatever you do in the middle, you have to do it on the left and the right, and then your interval is always going to have two numbers in it, and your graph is always going to have two numbers on it. All right, last one. Okay, so here we go. We're throwing a fraction at you, which we should be able to handle this without too much trouble. So anytime we have a fraction, to eliminate it, we could go ahead and subtract 4 and do all that. But we could eliminate the fraction first. So I'm going to eliminate the fraction first by distributing a 2. So I'm going to multiply everything inside by 2. So I'm going to end up with 6 is less than or equal to, so when I multiply that fraction by 2, it just becomes 3x. And then we have plus 8 is less than or equal to 10. All right, so now I've got rid of that fraction, so I can just solve like I normally would. So I'm going to subtract 8 on all 3 parts, left, middle, and right. So we have negative 2 is less than or equal to 3x, which is less than or equal to 2. All right, you'll notice we have less than or equal, so we got to be thinking I need brackets for both of my ends of my interval in this case. All right, but I'm not done yet, so I need to divide everything by 3. So I'm going to divide everything by 3 here. And in this case, I can't divide 2 by 3. I can't divide negative 2 by 3, so I just leave it as a fraction. So in the middle we have x all by itself, and 2/3 on the right-hand side. All right, so you might look at that and say, oh, we got a fraction. How can we do that in an interval? Well, a fraction is just a number, so we can put it in an interval. And remember, when we have less than or equal to, we're going to use brackets. So we have brackets on both sides. And we just put our two numbers in there, negative 2/3 and 2/3. Okay, so that might be strange for some people, but it's okay to have fractions in an interval like that. And then we can graph this one. And remember, we just want two numbers. We're using brackets for each one. So I'm just going to go ahead and put my brackets in there. And you know, you think of a number line, a traditional number line as all integers. Well, yeah, it's all integers, but really in between all those integers, there's a whole bunch of fractions. So it's okay to put fractions on your number line. And then we're going to shade everything in between. Okay, one thing I didn't mention is you can test this, your intervals out just by picking any number that's in the middle of your interval and substituting it into the original inequality. And if it ends up being true, then you know you have the right interval. So for example, in this case, we know that 0, here let's go with a different color. We know that 0 is right here in the middle between these two intervals, right, or these two ends of our interval. And if we come up here and if we plug 0 into our original inequality, if we plug 0 in there, that thing just goes away, right? Because 3 times 0 is 0, 0 divided by 2 is 0. So now the question is 4 between 3 and 5? Well, the answer is yes. So we know that we have something right about our interval. And the other way you could test it too is to pick a number that's outside of the interval and plug it in. And if you get something that's not true, then you really know you have the right interval. Okay, so now it's your turn to do the assignment that's on Schoology and submit that when you are done with it.